Whenever you see a rocket launch, it's just awe-inspiring, right? That raw, controlled power, a machine weighing millions of pounds just lifting off the ground and tearing a path straight into the sky, it looks like absolute magic, but really, it's just some of the most brilliant physics you'll ever see. So let's pull back the curtain and see how it actually works.
So that's the fundamental question, isn't it? Earth's gravity is this relentless force, constantly pulling everything down. To beat that, you can't just go up. You have to go up with enough speed to actually break free from that grip. And the answer to how we do that lies in one surprisingly simple, incredibly powerful idea. And that whole idea comes down to one word: thrust. It is the secret ingredient for all of rocketry, and it's built on a law of motion that's been around for centuries. And here's the kicker: it has absolutely nothing to do with pushing against the air. Okay, so you've probably heard this in science class, Newton's third law. For every action, there's an equal and opposite reaction. That's it. That's the whole principle. A rocket works by throwing stuff, in this case superhot exhaust gas, out of its engine as fast as it possibly can. That's the action. And the opposite reaction is the universe pushing the rocket forward. A great way to picture it is to think of firefighters trying to hold on to a powerful fire hose. The force of the water shooting out pushes them backward. That's thrust. Now, this is the really important part that separates a rocket from, say, a jet engine. A jet engine has to suck in air from the atmosphere to get the oxygen it needs to burn fuel. But a rocket is self-contained. It brings its own oxygen with it in a chemical form called an oxidizer. And that is the key that unlocks space travel, because it means a rocket engine can keep firing in the total vacuum of space, where there is absolutely nothing to breathe and nothing to push against. Of course, this amazing idea didn't just appear out of nowhere. It took centuries of tinkering, experimenting, and innovation. It's a journey that actually started with simple fireworks and slowly evolved into the incredible machines that can take us to other planets.
The story really begins back in 13th century China with gunpowder-filled fire arrows. For hundreds of years, that's pretty much what rockets were, weapons. But the real game changer was Robert Goddard. In 1926, his work with liquid propellants and special engine nozzles took rocket efficiency from almost nothing to something genuinely powerful. He basically wrote the rulebook for modern rocketry. By 1944, the V-2 rocket built on those principles and became the very first man-made object to actually touch the edge of space.
So we figured out how to go up. But just getting to space is only half the battle. Staying there? That's a whole other can of worms. You see, the next massive problem wasn't just about creating a push. It was about creating enough of a push to hit a very specific and very, very fast speed.
And that speed is 7,800 meters per second. Let me put that in perspective for you. That is almost 17,500 miles per hour. That's how fast you need to be traveling sideways, parallel to the ground, so that as gravity pulls you down, you're moving so fast that you constantly miss the Earth. You just keep falling around it. That's what an orbit is. But achieving that speed is ridiculously hard because of a really nasty bit of math.
People in the industry call it the tyranny of the rocket equation. And it goes like this: to go faster, you need more fuel. Okay, simple enough. But more fuel adds more weight to the rocket. And a heavier rocket needs, you guessed it, even more fuel just to get that extra weight off the launch pad. It's this vicious cycle that makes you feel like you're running in place. For a while, it made reaching orbit seem almost impossible.
So how in the world did we solve this impossible weight problem? Well, with one of the most clever and crucial engineering tricks in the history of flight. Instead of trying to build one single gigantic rocket to do the whole job, engineers came up with a brilliant idea: build rockets that are designed to fall apart in midair, on purpose. And this process is what we call staging. It's beautiful in its simplicity. You launch with these huge lower stages packed with fuel. Once that first stage has done its job and burned all its fuel, you just drop it. You get rid of the massive dead weight of the empty tanks and the giant engines. All of a sudden, the rest of the rocket is dramatically lighter. And now the much smaller engine on the second stage can easily push that lighter vehicle up to those insane orbital speeds. And I really can't overstate this. Staging is the breakthrough that opened up the solar system. Without it, the math just doesn't work. A single rocket big enough to carry all the fuel needed to get to orbit would be too heavy to even lift itself off the ground. Period. Staging is what makes modern spaceflight possible. So, we've talked about the physics, we've gone through the engineering challenges, but why does it all matter? I mean, what's the big deal? Well, it turns out this technology doesn't just let us explore space.
It has completely transformed our modern world right here on Earth. Just think about your day today. Did you use GPS to get somewhere? Check the weather forecast? Connect with someone on the other side of the planet? All of that depends on a network of satellites that were put in orbit by rockets. They are the workhorses of the modern age, powering exploration, science, communication, and even our safety, with things like life-saving ejection seats.
So you see, what started as a simple chemical reaction in a tube centuries ago has become a technology that allows us to literally leave our world behind. The entire history of the rocket has been about solving one impossible problem after another. How to beat gravity, how to fly without air, how to reach incredible speeds. It really makes you wonder, doesn't it? What's the next great problem that this incredible technology is going to solve?